In the summer of 2010, a heat wave settled over Russia, and what followed in its wake is estimated to have killed nearly 55,000 people. That number did not come from the heat itself. It came from what happened after. The heat dried out the landscape so severely that wildfires broke out across the country, and smoke blanketed Moscow for weeks, turning the air itself into a second, slower emergency long after the original heat had technically broken. Emergency rooms filled with people who could barely breathe. The death rate in Moscow roughly doubled during the worst of it, and by the time the smoke finally cleared, most of the world's attention had already moved on. Scientists have a name for what happened there: a compound drought and heatwave event. And a study published this year in Science Advances just found something about these events that even the researchers who ran the numbers are calling a genuine surprise. The relationship connecting a heatwave to the drought that often follows it has not simply been getting worse at a steady pace. It has become nearly 8 times more sensitive to global warming than it was 20 years ago. This is what actually happens after a heat wave ends, why the danger frequently doesn't end with it, and what's now driving that danger to intensify faster than the scientists studying it expected. If you've lived through a heat wave that turned into drought or wildfire smoke where you live, tell me what that transition actually looked like in the comments. I read every one of them. And if you want grounded science coverage instead of panic headlines, subscribing helps this reach people before their own heat wave's aftermath arrives. To understand what this research found, you first need to understand what scientists mean by a compound drought and heat wave event, or CDHW for short. A stretch where drought and extreme heat show up either at the same time or in close sequence in the same place. The order they arrive in turns out to matter enormously, because each sequence runs on a completely different mechanism. When heat comes first, intense sun and high temperatures pull moisture out of soil and plants faster than it can be replaced, and that accelerated drying is what tips the region into drought behind it. When drought comes first, the mechanism runs in reverse. With less moisture in the soil to begin with, less of the sun's energy gets absorbed by evaporation, the process that normally cools the surface, so more of that energy goes straight into heating the ground and the air above it, setting up conditions for a heat wave to follow. Both sequences can turn dangerous, but the research team found that one of these two pathways has been growing dramatically faster than the other, and it's the one that starts with heat. That matters if you're trying to figure out what comes next after a specific heat wave, because a region that just endured one is now measurably more likely to be watching the start of a drought than it would have been watching that same heat wave 20 years ago. The headline number is striking on its own before you even get to the surprising part. Comparing 1980 through 2001 against 2002 through 2023, researchers found the total land area affected by heatwave-led compound events had increased by 110%, more than doubling in just over 2 decades. Drought-led events increased too, but by a smaller 59%, meaning the heatwave-triggered pathway is now the dominant, fastest-growing driver behind these compound disasters worldwide. Globally, most compound events still technically start as a drought, but the heatwave-led category is the one reshaping the overall trend, and the one the researchers say deserves the most urgent attention going forward. Here's the part that genuinely surprised the scientists involved, and the reason this story matters more than the headline number alone suggests. Rising temperatures don't fully explain what they found, because the relationship between warming and these heatwave-led events hasn't been a straight line. In the earlier period, from 1980 to 2001, the spatial extent of these events increased by 1.6% for every 1 degree Celsius of global warming, a modest, roughly proportional relationship. In the more recent period, 2002 through 2023, that same sensitivity jumped to 13.1% per degree, an increase the researchers describe as nearly 8-fold. That's not the same trend continuing faster. It's a fundamentally different relationship than existed 20 years earlier. The researchers even pinned down roughly when and why. The shift lines up with global average temperature, based on an 11-year running average, crossing about 14.3 degrees Celsius, a threshold the planet passed right around the year 2000. After that point, they found what they describe as a regime shift, a lasting structural change in how land and atmosphere interact, not a temporary blip that might reverse on its own. That's a genuinely different idea from ordinary gradual warming. It implies the rules connecting heat and drought didn't just scale up smoothly. They reorganized into a new, more volatile configuration once the planet's average conditions crossed a specific threshold. Not unlike how water doesn't gradually become steam, it transitions abruptly once it crosses its boiling point. Sang-Wook Ye, a climate scientist and one of the study's authors, explained the mechanism directly. When heat waves and droughts occur together, the two hazards reinforce each other through land-atmosphere interactions, amplifying surface heating and soil moisture loss at the same time, which makes compound events considerably more damaging than either hazard occurring alone. That reinforcing loop is exactly why sequence matters so much to researchers studying this. A heat wave doesn't simply end when the temperature drops. In a growing number of regions, it hands off directly into a drought the heat itself helped create, and that handoff has become faster and more severe since land and atmosphere shifted into this more intensified state after the late 1990s. The real-world consequences aren't hypothetical. Beyond the Russian sequence of 2010, with its estimated 55,000 deaths, that year's grain harvest collapsed by roughly a third as drought scorched crops already weakened by weeks of extreme heat. Severe enough that Russia imposed a temporary wheat export ban that rippled into global grain prices. A more recent example comes from the Pacific Northwest, where the record-breaking 2021 heat dome directly triggered extreme drought afterward, causing significant declines in wheat, barley, canola, and fruit production across British Columbia and Alberta. In both cases, the heat wave itself grabbed the headlines, while the drought and wildfire consequences that followed weeks later, arguably the more damaging phase of the entire event, got considerably less sustained attention, even as the losses kept accumulating. This isn't confined to a handful of unlucky places. The study identifies northern South America, the southern United States, Eastern Europe, Central Africa, and South Asia as the regions experiencing these compound events most frequently, a list that overlaps directly with several regions that have already endured record-breaking heat this year. Several of these high-risk regions also already deal with chronic water stress before any single heat wave even arrives, meaning a compound event landing on an already strained water system can escalate considerably faster than the same event would somewhere with more resilient infrastructure. There's a genuinely important lesson in how sharply this relationship changed after 2000, and it's worth sitting with rather than treating as an academic footnote. Most public understanding of climate risk still assumes something roughly linear, a little more warming, a little more drought risk, in a predictable, proportional way. This research found something less comfortable. Once global temperature crossed a specific threshold around the turn of the century, the relationship between heat and the drought that follows didn't just keep scaling up gradually, it shifted into a regime nearly 8 times stronger than before. That means how a heat wave in your region historically turned into drier conditions afterward may simply no longer be a reliable guide for what happens next, because the underlying physical relationship producing that transition has changed shape, not just scaled up along the same curve it always followed. The useful part of this story is that it isn't a warning without a response attached to it. Dr. Mariam Tanarte, a climate scientist at the University Hassan II in Morocco, who wasn't involved in the study but reviewed its findings, points out that these compound events can be forecast up to 10 days ahead in many regions. Real, actionable lead time if that forecasting capacity is actually used. Dr. Ruth Cerezo Mota, a climatologist at Mexico's National Autonomous University, who also reviewed the study, has noted that its global scope is one of its biggest contributions, since regions like Mexico and parts of Africa have historically lacked the data and research infrastructure to study these events locally, not because the events don't happen there, but because the tools to study them haven't reached everywhere yet. Both researchers agree the worst impacts can genuinely be reduced through preparedness already available today: better agricultural water management, targeted heatwave mitigation, and proactive wildfire mitigation carried out before a compound event fully develops. The study's authors go further, recommending that risk management strategies be reassessed specifically to account for the sequence in which drought and heat arrive, rather than treating every hot, dry stretch as functionally identical, regardless of which hazard triggered which. So what does this actually mean for you? Especially if you've just lived through, or are currently living through, a major heat wave anywhere in the world. It means the days and weeks immediately afterward deserve real attention, not a collective sigh of relief the moment temperatures drop back to normal. If you're in a region that just endured extreme heat, particularly the southern United States, Eastern Europe, or the other high-risk regions this research identifies, it's worth watching drought monitors and wildfire risk indices over the following weeks, rather than assuming the danger passed with the heat.
If you work in agriculture, the Pacific Northwest's 2021 experience is a direct, practical warning that crop damage from a heat wave's aftermath can rival or exceed the damage from the heat itself, arriving weeks after the story has already left the news cycle. If your region just went through a heat wave and local water authorities haven't issued conservation guidance yet, it's worth asking why, given how much more sensitive this pathway has become since 2000. And if your region has access to the kind of short-range forecasting Dr. Tenarte described, checking it in the immediate aftermath of a major heat wave is no longer a niche precaution. It's a genuinely useful habit, worth building into how you track weather going forward. The grounded summary is this. A study published this year in Science Advances found that compound drought and heat wave events have surged worldwide since the early 2000s, with events that begin as a heat wave and trigger drought increasing their affected land area by 110% since the turn of the century, nearly double the growth rate of events that begin as drought instead. That increase isn't simply proportional to rising global temperatures. It became almost eightfold more sensitive to each additional degree of warming after the planet's average temperature crossed roughly 14.3 degrees Celsius around the year 2000. A shift researchers describe as a genuine regime change rather than a continuation of a previously steady trend. Real-world consequences of this exact pathway include an estimated 55,000 deaths tied to Russia's 2010 heat wave, drought, and wildfire sequence, a roughly one-third collapse in that year's grain harvest, and significant crop losses across Western Canada following the Pacific Northwest's 2021 heat dome. Researchers say the worst impacts can genuinely be reduced through better forecasting, water management, and proactive wildfire mitigation, but only if a heat wave's aftermath gets treated with the same seriousness as the heat wave itself, instead of being written off the moment the temperature finally feels normal again. We'll keep tracking how this year's heat waves evolve in the weeks after they break, sourced the same way we did today, straight from Science Advances, the researchers behind the study, and the climate scientists who reviewed it, not recycled headlines dressed up as breaking news. Subscribe if you don't want to miss whether a compound drought or wildfire event follows any of the heat we've already covered this summer, because based on this research, that follow-up is becoming more likely with almost every heat wave, not less. And tell me in the comments, has the heat where you live ever been followed by drought, wildfire smoke, or water restrictions in the weeks after? Because behind every one of these compound event maps is a family in Moscow who lived through weeks of wildfire smoke long after the headlines about Russia's heat wave had faded, a farmer in Alberta watching a canola crop fail from drought that arrived only after the record heat dome had already passed, and a research team in South Korea that looked at over 40 years of daily weather data and found a threshold nobody had fully mapped out until now.